रीड द क्वेश्चन। अरे यार आप लोगों को, आर यू माय डियर लविंग स्टूडेंट्स, आर यू फॉलोइंग? देखो, द फिगर शोज एंड द हाईलाइटिंग पॉइंट इज steady state data for a composite hot plate and two solid layers. Hot plate and two solid layers. The ambient temperature is 300. Okay. The Exergy destruction in hot plate. The Exergy destruction. Oh, mast question है sir. आराम से. Please. I'll explain what this question is all about. My dear students, understand this question. यहां से कुछ वर्क आ रहा है सर, वर्क इनपुट. Some electrical input is given and there is a hot plate. हे भगवान, this is a hot plate. There is a hot plate. Now, there is layer 1. And there is layer 2. Understood, sir. Actually, physically, let us feel it, what exactly is happening in this question. Physically. Clearly, he said it is running under steady state conditions. Okay. The electrical work is transferred and this is all insulated, sir. ये पूरा insulated. देखो, clearly it is given as insulation. The electrical work is transferred to the hot plate. And from the from the hot plate, there is a heat transfer to this. क्योंकि ना, when you are transferring the electrical energy, it becomes hot. So from the hot plate, heat is transferred. From hot plate, heat is transferred to layer 1. From layer 1, heat is transferred to layer 2. From layer 2, the heat is transferred to the surroundings. Let me repeat. There is an electrical energy given. I don't know how much it is given. So because of that electrical energy, this is becoming hot. From the hot plate, heat is transferred to the layer 1. From layer 1, the heat is transferred to layer 2. From layer 2, heat is transferred to the surroundings. लेकिन यहां पे फिगर में कुछ डेटा मिसिंग है सर. आई विल सप्लाई द डेटा. द डेटा इज दिस टेम्परेचर. देखो ये वाला टेम्परेचर, ये वाला this is given as 1000 Kelvin. This is given as 600 Kelvin. And this is given as 400 Kelvin. These are given, sir. And what is the surrounding temperature given, sir? Surrounding. The surrounding temperature is 300. Understood, sir. See the beauty of the question. कितना प्यारा सा क्वेश्चन है सर. अब देखो, you love this, sir. सर इतना कितना अच्छे क्वेश्चंस करवा रहे हैं सर आप. हाँ मुझे पता है. देखो सर, ये हॉट प्लेट लीजिए सर, दिस इज द हॉट प्लेट, देखो देखो, दिस इज द हॉट प्लेट, you know very well this is all insulated. देखो ये सरफेस इंसुलेटेड, ये सरफेस देखो, दिस बॉटम वन इज इंसुलेटेड, दिस राइट साइड इज इंसुलेटेड, लेफ्ट साइड इज इंसुलेटेड. ठीक है सर जी. ठीक है, बहुत केयरफुली देखो. फ्रॉम द लेफ्ट साइड व्हाट इज ट्रांसफर्ड सर, फ्रॉम द लेफ्ट साइड व्हाट इज ट्रांसफर्ड, वर्क. देखो देखो, लेफ्ट साइड से वर्क आ रहा है सर. इलेक्ट्रिकल वर्क इनपुट, देखो इलेक्ट्रिकल वर्क इनपुट. अभी कुछ है सर, एनीवन? अभी कुछ है सर? गेस मारो सर, गेस मारो. This temperature is given as this. Guess मारो सर. मेरे प्यारे दोस्तों, the system is under steady state conditions. So if the work is continuously given to this, ध्यान से सुनिएगा सर, अगर वर्क कंटिन्यूसली दे रहे हैं, if the same amount is not going, it cannot reach the steady state. Because already he said all the systems are running under steady state. तो अब आप बताओ, how much heat should go out? Anyone? Whatever is entering, that should go out. ये कहां जाना चाहिए? From the hot layer, it should go to the layer 1. Wonderful, sir. Common sense says, देखो एक बार, जितना आ रहा है उतना जाना चाहिए, अदरवाइज इट कैनॉट बी स्टडी. गेस मारो, हाउ मच वर्क शुड बी गिवन सर? गेस, कितना वर्क देना चाहिए सर? आप गेस मारो सर. अरे यार 1000 जब बाहर जा रहा है, सॉरी 1 किलोवाट जब बाहर जा रहा है, तो 1 किलोवाट शुड एंटर. सो द वर्क इनपुट इज इक्वल टू 1 किलोवाट. सो द हीटर कैपेसिटी, जो हीटर है हॉट प्लेट, इट्स कैपेसिटी इज 1 किलोवाट एंड 1 किलोवाट इज गोइंग आउट. दिन ओनली. देखो अगर 1 जा रहा है तो यहां से देखो, वॉट एवर इज एंटरिंग दैट शुड गो. इफ 1 इज गोइंग, 1 शुड एंटर. दिस इज द फ्री बॉडी डायग्राम हॉट प्लेट का. होप यू अंडरस्टूड दिस. क्लैरिटी आ गया सर? ये हॉट प्लेट का है सर. अब एक काम करते हैं सर, दिस इज फॉर द हॉट प्लेट. नाउ आई विल टेक layer 1. सुनिए सर, देर इज हाई क्लैरिटी. देखो एक बार, व्हाट इज द क्लैरिटी? द लेफ्ट फेस ऑफ दिस इज इंसुलेटेड, द राइट फेस ऑफ दिस इज इंसुलेटेड. व्हाट इज द लोअर टेम्परेचर? दिस टेम्परेचर इज 1000. व्हाट इज दिस टेम्परेचर? से ये वाला 600. Now, from the hot plate, how much is entering? ध्यान से सुनिए, hot plate से कितना आ रहा है सर? देखो ये देखो, hot plate से, so जो जा रहा है, so from this hot plate, Q is entering. So therefore, this Q is 1 kilowatt. And tell me, layer 1 से something is going to layer 2. कितना जाना चाहिए सर? It is a steady state. Whatever is entering, the same should leave. Hope you understood, sir. Hope you understood, sir. This is very interesting question, sir. very interesting question. जितना आ रहा है उतना जा रहा है. Now, let's go to layer 3. तो आप बताइए सर, Obviously, how much is going, sir? So if 1 kilowatt is going from the layer 1, this layer, 1 kilowatt should enter. Excellent, sir. Excellent, sir. तो नीचे वाले का टेम्परेचर कितना है सर? देखो एक बार, नीचे वाले का लेयर 2 के 600 एंड दिस इज 400 केल्विन. नहीं है सर. प्लीज टेल मी इफ दिस इज क्लियर. आई विल प्रोसीड सर. वेट, कुछ नहीं है सर, कुछ नहीं है सर. एंड एक भूल गए सर, this side is insulated. You should not forget, because the left and right are insulated. Wonderful, sir. If this is clear up to this, I will proceed, sir. कुछ नहीं है सर, जितना आएगा उतना जाना है, because it is steady state. So if the leaving is given as 1, entering should be 1. So it is entering, work input is 1. So if it is 1, yahan se from, this is not insulated. Only this and bottom are insulated. So when the work is entering, the temperature increases, from this heat is transferred. So as 1 kilowatt is entering, 1 kilowatt will go. But from this it is entering the layer 1, and from this it is going, so entering and leaving. And from this it is entering and it is leaving. This is the question, sir. So if there is any problem in understanding this, you ask me. If this is clear, I'll proceed. Now, what is the work input, sir? It should be 1 kilowatt. So, pehle dekho. The power input provided to the compressor section is 1 kilowatt. It is correct. Is the electrical power input 1 kilowatt correct? 100% correct hai, sir. 100% correct hai, sir. It is correct. Because he is asking the electrical power input. So, the electrical power input is 1 kilowatt. Ab dekho, sir. भाइयों बहनों, अब देखिए, आइए सर, ध्यान से सुनो. एक बार इक्वेशन कंस्ट्रक्ट करके देखेंगे. ही इज आस्किंग इन द क्वेश्चन एक्सर्जी डिस्ट्रक्शन. कैन यू टेल मी द मीनिंग ऑफ एक्सर्जी डिस्ट्रक्शन, सर? Meaning of exergy, irreversibility. The meaning of exergy destruction is irreversibility. True. This is insulated. हाँ जी सर जी, टेंशन नहीं लेने का सर, टेंशन नहीं लेने का. ये कंप्लीटली, अरे यार, यस, वाई सर. वेट, आप टेंशन मत लेना. आई सेड टेंशन लेने का ही नहीं. देखो सर, एंड दिस इज इंसुलेशन. ये पूरा मेरे प्यारे दोस्तों, भाइयों बहनों, देखो एक सेकंड. आई नो वन इक्वेशन. इफ देर इज नो मास ट्रांसफर, मेरे पास एक इक्वेशन था, इधर देखो, कहां लिखेंगे? ds इज इक्वल टू d डैश क्यू बाई टी plus del S generation. If there is a mass transfer also, यहाँ पे we'll write that also. अब वो भी देखेंगे sir, don't worry. No, it is a closed system. A closed system. Suppose I write in rated form. What do you mean by rated form? With respect to time. तो यहाँ पे dot आएगा, यहाँ पे dot आएगा. Very good, sirs. Clearly, he said it is a steady state. Whenever it is a steady state, what is the change of entropy with time? This will be 0 because it is a steady state. So my equation becomes under steady conditions when there is no mass transfer. Under steady conditions when there is no mass transfer, this will be equal to 0. This will be equal to 0. That's it, sir. At least have you understood? So once the entropy generation is known, so irreversibility will be equal to T naught into entropy generation. That's it, sir. So already T naught is given as 300. You calculate the entropy generation in each case. Dekho. First, in the hot plate. Dekho. What is the equation, sir? My equation is, dekho. D dash Q by, this is the equation. Why? Because actually, ds by dt is d dash q by t plus del S generation. Steady state के कारण there is no change of property with time. This will be 0. When this is 0, d dash q by t plus del S generation is 0. तो put करो. Why this term is coming? Because of entropy transfer. ये term किस कारण आ रहा है? Because of entropy transfer. ध्यान से सुनिएगा सर. So let us take the hot plate. अब देखो कहां से देखो hot plate के लिए कैलकुलेट कर रहे हैं. You are calculating the entropy generation for hot plate. From the hot plate, heat is moving out. The transfer of entropy will be the same. The direction of entropy transfer is same as heat transfer. तो ये बाहर जा रहा है. तो hot plate के लिए ये बाहर जा रहा है. So will this be plus or minus? It will be minus. So therefore it is going out. It will be 1000. Sir, why 1000? Because it is kilowatt. I have converted into what? By किस temperature से बाहर जा रहा है sir? It is 1000 Kelvin. Let me repeat sir. Let me repeat. इधर देखो. So यहां से कोई heat transfer नहीं, यहां से नहीं. So from this system, it is going out. Out for the hot plate, going out means minus. So Q by T, Q by T, Q by T. This Q is minus 1000 by T. Temperature is 1000. So what is the entropy generation, sir? One watt per Kelvin. So what will be the irreversibility in the hot plate, sir? T naught into delta S generation. T naught. What is T naught? 300 into entropy generation. What is the entropy generation? 1. So this will be equal to 300 watt. Is it clear, sir? Or 0.3 kilowatt. Please बताइए क्वेश्चन समझ में आया सर. देखो 0.3. एक सेकंड. 300 watt is nothing but 0.3 kilowatt. This is the Exergy destruction or irreversibility in the hot plate. In the hot plate, it is 0.3. बिल्कुल सही है सर. बिल्कुल. Have you understood, sir? 100% correct है sir. Now come here. The same equation. देखो एक second. For all these, I will write the same equation because ds by dt is d dash q by t plus del S generation. Very good. But as it is a steady state, this will be 0. So it will be d dash q by t plus del S generation is equal to 0. देखो. हाँ, अब देखो. But here there was only one transfer. Here there are two. At this temperature 600 it is entering. So whenever I am calculating for layer 2, for layer 2 entering is plus, for layer 2 leaving is minus. So एक काम करते हैं सर, इधर देखो. So 1000 because I am converting kilowatt to watt by at what temperature 600 it will be plus. Why it is plus? Because it is entering. Now this is leaving. तो ये वाला कैलकुलेट करो सर, ये वाला. So there are two heats. One heat is at 600, other is at 400. So therefore Q by T. This Q 1000 is occurring at 600 Q by T plus, and it is leaving. So minus 1000 by 400 plus entropy generation should be equal to 0. What is the entropy generation in layer 2? No one is giving answer, sir. What is the entropy generation in layer 2? इतना ऐसे लोगों को पढ़ाना थोड़ा मजा नहीं आ रहा सर. So irreversibility will be equal to T naught into delta S generation. T naught is given as 300 into 0.833. It is 250 RI, sir, 250, and this is 250 watt, or this can be written as 0.25 kilowatt. So in the second layer, the irreversibility is 0.25. The second layer, it is 0.25. Bilkul correct hai, sir. In the layer 2, it is 0.25. Now please calculate in layer 1. Anyone in layer 1? Jaldi calculate karo, sir. Please calculate in layer 1. Very simple. The same equation, ye wala. D dash Q by T plus del S generation. D dash Q by T plus del S. तो ये अंदर आ रहा है प्लस 1000 बाई, देखो इट इज लेयर 1. ये 1000 है सर. हाँ, this is 1000. At 1000 it is entering. This is entering, so 1000 it is plus, minus, it is leaving. 1000 is leaving. At what temperature it is leaving? 600 plus entropy generation, and that should be equal to 0. Anyone? कितना आ रहा है सर? 0.666. So irreversibility will be equal to 300 into 0.666. कितना आ रहा है सर? What is irreversibility? So it is 200 watt or 0.2 kilowatt. So in layer 1 it is 0.2. वाह, क्या मस्त क्वेश्चन था सर. आया नहीं है सर. What a beautiful question this was. सीरियसली बताओ सर. आप बोलते नहीं सर. दुख लगता है सर, दुख लगता है. बताओ, इज इट अ गुड क्वेश्चन और नॉट? सो कुछ भी टफ क्वेश्चन देने दो सर, आप डरो मत. नो मैटर व्हाट द टफनेस ऑफ क्वेश्चन इज, आप डरो मत सर.